All right, page 2 of the test review here has a piecewise function. We're asked to graph this and find the domain in the range. So as far as the graph goes, what I always want to do is kind of look at my transition point, which is -3 here. And when we're less than -3, so when we're to the left of this, we are this line here, this line that has a y-intercept of +3 and a slope of -1, going down 1 over 1. So I can kind of get a little trace of that line, but again, it doesn't really work for this equation until you're at -3 or before. So if I kind of trace this out, I can make a rough little trace of it like that. It stops again at -3 up here at a value of 6. Okay, so that's that. And then if I were to put -3 in, I know I'm getting a quadratic here. It's a parabola that's turned upside down, but exactly what part I'm looking at, I don't quite know. So maybe I could, say, well, it has a y-intercept of 4 and opens down. I could try to do something like that. But again, probably the easiest thing to do if you ever get concerned or confused is just throw the number in. -3 squared is 9. We're going to put a negative in front of it. So -9 plus 4 would be a -5. So right there. Okay. If I were to put -2 in, I'm going to get -4 plus 4, which is 0. If I were to put -1 in, I'll get -1 plus 4, which is 3. And if I put 0 in, I get 4. And then when I put +1, +2, +3, you see I can get this to kind of mirror itself on the other side and then go forever in that direction. All right, so it tops up here at +4 and started down there. Now, that's what the graph looks like. And again, it's kind of hinges on that transition. So first thing, again, I would do if I were you is look at your transition and then ask yourself, well, what's happening to the left of it? What's happening to the right of it? And then go from there. Now, as far as the domain goes, were there any x values that we did not include here? So there was no reason that we couldn't square something. There was no reason we couldn't do that. We included every value that was on our spectrum, so our domain would be all real numbers. Okay, we did not leave anything out. Again, the things to be concerned about would be a square root if they made it negative underneath, or a denominator where you couldn't equal 0 on the bottom. Something like that we'd be concerned about, but otherwise we feel pretty good. Now, as far as the range goes, we're looking for what values could this function be. So right away we see that this function is going to decrease forever and ever. So it can be anything negative, any value, negative value you can come up with, this function will be able to equal to, and it'll do that all the way up to +4. So we have part of this range is from -infinity all the way to +4 and including 4. It was could equal that. And then the other part of this graph starts at 6 but doesn't include 6 and then goes up forever. So any positive value above 6 could be included too. So we'll go from 6 but not including 6 all the way up to +infinity. So that would be our range right there. In other words, it's everything except for the numbers between 6 and 4 and not 6 as well. All right, then we were given two functions here, asked to find some information here. F of -5, simple enough. We put -5 in. You just want to be careful, especially if you were going to use a calculator, not to make that silly mistake. But we could just do it in our head. -5 squared is 25, so 1 minus 25 is a -24, and that's our answer. F of g of x means we're taking the g function, we're putting it into the f function. So you're going to take the whole 2x plus 1, and you're going to put that right in there. So we're going to get 1 minus 2x plus 1 squared. Now, technically that is the composition. You wouldn't necessarily have to go further if that's what they asked for, and this was free response. You would be done. If it was multiple choice and they didn't show this, then that means they probably did square this out, so you'd have to FOIL that out, which would be 4x squared plus 4x plus 1, and then you'd have to subtract each of these. So you'd have a -4x squared, you'd have a -4x, and then 1 minus 1 would be 0. So that would be the full simplified, but again, there is nothing wrong with this either. That is legitimately the right answer too. It's just that this has been expanded out. And then g of f of 3 means we're going to put 3 into the f function, so we're going to get 1 minus 3 squared. So that's 1 minus 9, which is negative 8. That's what f of 3 is. So now instead of f of 3, I'll put what it equals, which was 8, or negative 8. And we'll put that into the g function. So now we're going to go 2 times negative 8 plus 1, which gives us a negative 15. So start on the inside, do that, then work your way to the outside. All right, and then our last problem here on this page asked us to find this inequality, absolute value greater than 5. So again, right away what I do is forget the 2x minus 1, ask yourself what numbers have an absolute value that's bigger than 5. And those are numbers that were already bigger than 5, 6, 7, 8, 9, things like that. Or could have been numbers that were less than negative 5, like negative 6, negative 7. Both of those are options of numbers that have an absolute value less than 5 or greater than 5. So that means 2x minus 1 could be either one of those. So we have to consider both of those. Once you have them set up, then again, it's pretty simple. We're going to add 1, divide by 2, and so here's one set possibility. X could be less than or equal to negative 2. That's from negative infinity to negative 2. Including negative 2, but obviously we can't equal negative infinity. Over here, if I add 1 and divide by 2, I get x greater than or equal to 3. So those are numbers that are bigger than 3 all the way out to infinity. So x can be anything in here. Can't be anything in between negative 2 and 3, but it can be anything else to satisfy this.